Okay, let's do this sorted array rotated array problem. Um, I think I have two more. I've never done these before, I believe. So yeah, that's nice. We've done a decent amount of problems. I've never touched like the math and geometry stuff and the bit, but it is what it is. Okay, hold on. I've done this one before, but it's been a while, so I probably might. I don't know if I don't know if the solution. I think it was something like the first one is basically there's some pivot and then you have to find like the binary search. So like right here is yeah, like for example, like something like this. Um, Pivot index 5, we just basically add 5 to everyone. Like 0 goes to, so 5 0, that'll be 5, so 0 1 2 3 4 5 end up here, so 0 1 2 3 4 5. So yeah, everyone gets adjusted by some pivot value, but it's still assorted. So yeah, but this one, I think the thing is nums is it could contain duplicates. So would that change anything? I'm not sure. I don't know how this is gonna work out. So let's see. So the target is defined as 0. So I don't know. Would this change anything? Well, okay. I know that it's the idea is having to like a pivot. So are we on the? Are you on? So once you calculate the mid, check if we are in the mid, or check if you're on the left side of the pivot, or the right side. Else we are in right side. So what does that mean? That means, okay, let's say I do the, so what is this? 1, 2, 3, 4, 5, 6, 7, right? There's 7 values. 7 divided by 2. Round down is 3. So index 3 is 0, 1, 2, 3. This is our middle value, right? So that's our middle value. Basically, where am I in this pivot? So am I towards the lower side or higher side? We can't really tell. But the thing is, I know that duplicate values. So like, if this wasn't had duplicates, for example, right? 2 5 6 0 1 2. We know that duplicates are gonna be next to each other because they're still sorted. So maybe I can have like the next non-different, like the next value that isn't the duplicate, right? Like as long as like keep finding the next non same number. So like this would be like the other problem here, I think, the search sorted array. Like well, okay, first off, I don't know if I would be in this middle here, but hold on. Let me recalculate. This is 6 now. I think we would be biased towards the left. Let me double check. So 3, so it's 6 divided by 2, that's 3. 0 1 2 3. Okay, still never mind. We're biased towards the right side. Never mind. So 2 5 6. So we're still here actually. Now I just need to tell, am I in the left side of the pivot or the right side of the pivot? So the if we're on the left side, that means we are saying that the middle is less than here. The middle is greater than, yeah, the middle is less than the value before it. Right? I think that makes sense to me. So that means we are on the smaller side, right? meaning we are on the smaller, right? If we're on the right side, that means we were like here. We're on the right pivot, right? So that means the number is bigger than the one next to you, right? But if there's duplicates, that does cause a problem because when you check the left and right, we don't know. Like you could be on the endmost. There could be like a shit ton of here, right? And you could be in the middle one and you check both sides. But my idea is we just ignore duplicates basically, as long as you're not the value, of course, right? That's my guess. So okay, so I have an idea now. So let's do a normal bounding search. We do left, right, 0, length of nums -1, while L. I think I'm gonna include the values that they end up being at the same, just to be safe. We can get rid of it if it starts being weird. So we'll do the calculate. So we'll do middle. We'll do, which is left plus R, round down to 2. Then if the nums of mid, brother, equals target, return true. So that's like really a happy case. But now this is most likely not the case. Okay, also, I'm probably going to return false if I can't find anything. Okay, so now we'll have our pivots here. So I have to adjust the left and right real quick. So first, I need to check. I need to basically peek the left side. Peek the right side until they are not the same value, because we don't really care, because we know that the neighbors are going to have the same values, right? Peek the left side until they're not the same value. Peek the right side until they are not the same value. Then we do the check of where we are in the left to right pivot, right? Because I want to be actually the endmost here, right? Because I want to compare 0 and this. Like I don't really care about this 0 here. So let's try that. So how would I do this? Let's do leftmost, which is just L. Rightmost, which is just R. Then I'll do while leftmost. First, I definitely want to check leftmost is positive. Positive, so it's greater than -1, right? And equals our nums of leftmost. Or what am I saying? Equals our current left, right? Right. Then we'll do leftmost, and we'll just increment nice like that. And we'll do the exact same for rightmost. So rightmost with the right, and then we'll do rightmost. Also, I need to make sure that this is the right boundary length of nums, so we don't go way too far out, right? So these are the important pointers here, because peek the left side until they're not the same value. Because yeah, that just makes most sense to me. Okay, so now we do the comparison here. So we'll do. So now we have this sorted array. Now we're comparing this and this and this, right? Oh wait, I just messed up. hold on. Let me check. So I'm checking right now. I don't want to budge this at all. I actually want to budge this one. So the rightmost. Okay, I do need to increment. Oh wait, I did this really wrong. Oh no! I should have done. It's actually m here. M minus 1. Yeah, so which is this and this. And basically, so the minus 1, that's not going to execute, so we'll leave it. The plus 1. Yeah, we do need a plus 1 here. Plus 1 is equal to it, so we do increment it by 1 more. And now it doesn't equal, so yeah, we're good now. So now we have the 3 neighboring values that are not thing. Now we can do the check if like where we are. So if the, let's say, how do I detect this? So right now, this pivot is, I'm on the left. Yeah, the left side. So that means we're saying that the nums of mid, right, is smaller than or equal to actually it's greater than or equal to, oh, we could say this, nums of leftmost, right, is less than or equal to or I would say less than, because we actually will skip duplicates, right? Okay, so we say here, so we do, okay, so we're in the middle. Nums of leftmost is less than the nums of mid. No, it's the opposite. It's greater than. So that, yeah, that's what I meant here. So that's why nums of mid is less than or equal to. Okay, not equal to, because I actually care about that. Right? So that's saying this is smaller than this. So that means we're on the left side of the pivot. So another case is if it's ascending, like normally, then we are on the, we're on something else, you know? So, like, for example, if we're ascending correctly, like, let's say this was the pivot, right? So this is saying the middle is greater than the leftmost. So, yeah. If it's the middle is greater than the leftmost, then that's really good. Well, no, okay, that means what are we on? Well, that's 2 different cases. Never mind. So now this is the case where we say, okay, left. We were saying we're on the pivot, meaning that's basically we found the pivot. That means that is the leftmost value. We found here, right here, right. So the leftmost value here. Now there's 2 cases. Where do I go? Okay. So first thing is if nums of m is greater than target. Well, now, okay, that's not gonna be good. Let's do this one here. So probably, I think this is the middle. So we found the pivot. We said that, okay, now where do we need to go? The target is, okay, if the nums of greater than target, right? Or nums of L. Okay. Where do I pivot? So if nums of is greater than target, okay, that's literally not possible. So Okay, so if it's less than target, right? That means it's smaller than the target. We need to move up, so we'll do L equals M plus 1, right? Else, that means we're saying nums is bigger than the target, right? Nums is bigger than the target. Nums is bigger than the target. Oops, what am I saying? Nums is bigger than the target. For like this case, we need to actually go towards this way. Oh, wait. Does that make sense? Nums of the middle is smaller than this. Okay, I see. Let's say you're smaller than the target, or, right? Or, like the leftmost value is actually bigger than that. So nums of L is actually bigger than target. Then it has to be towards this. So we need to move here to it has to be towards here. Like at least it should be around there, right? Else, that means that means it could been so nums of less than target. Either that failed, meaning the middle is less than the target, so that means it's bigger than the target. So that means we need to move towards the right. So we want to go towards the bigger side of the thing. So R minimize 1. So now let's say we're on this side, right? This side of the pivot, right? Meaning this middle is actually bigger than the leftmost. Not the leftmost. Yeah, this is bigger than the leftmost. Then we're definitely on the bigger side, so we need to either go smaller or bigger, right? So if nums of M is too big, right, than target, or nums of R is if it's bigger than target or smaller than target, then we probably want to move that direction. So we'll do mid plus 1, else L equals mid minus 1. Okay, these are, I don't know if this works, to be honest. Let's try it, I guess. Yeah, it's probably like an infinite while loop. Yeah. Okay, I think this is okay. Screw this. Screw this. So let's do this. I feel like the peaking idea is good, but it's just wrong. I should maybe okay. If we end up in a duplicate, right? Then like if we end up here, that's fine. But if we end up like L and M is like here, then those are bad because we can't compare correctly. Like, right? Okay, so let me toss this real quick. So we're saying if the nums of M equals nums of L plus 1, and then continue, then we can do our check here. So if we're saying nums of L is less than or equal to nums of mid, okay, that means the left is smaller than the middle. That means we're on the right side of the left portion of the sorted pivot. This is the left portion of it. What I mean by that is from the pivot, this is all the values from here and on beyond, you are going to be smaller than the pivot. Or not necessarily, yeah, it's small, I guess, but like on the left side towards the pivot. If this is smaller, so we're saying if actually nums of L is actually bigger, so like let's say nums is here. Well, okay, so let's see this, and then so we're saying L is less than. So yeah, that means we're on the left side. If you're ascending normally like this, like no, nums of. Yes, we're on the left side. This is what I'm saying. So if here and here, that means you're on the right side. Yes, that's the right side. I keep getting mixed up. So here is the right side. Okay, so if yeah, that means you're on the right side of the thing. Like you're you are on the right side of the pivot. Or left side? What am I saying here? I'm saying this is bigger than this side. Then we have to kind of adjust accordingly. If you're just on a normal, like you're on a like ascending normally, right? Like this and like, let's say you're here and here, right? Or for whatever reason, then you're on like a normal side, or like you're in ascending order. So yeah. So okay. Anyways, this is the case. So if you're like in like the middle of these, right? Like in the middle of like an ascending array, so if nums of L, right, less than equal to target, not target, sure, or nums of equal to middle less than equal to nums of target, right? So let's say target is, so let's say you're here, right? So that means L is smaller, you're right above the L, and you're going to be and you're also smaller than your target, then it has to be the case where you go here. You want to go more towards left. You want to bring up left towards this direction. If it violates that, right, you're too big, so go towards the right. Now let's say you're in a like this scenario. So that's saying the left and the middle is, the left is bigger. The left is bigger than the middle. For example, like this scenario. The left is bigger than the middle. That means you're in exactly the pivot, right? So if that's saying if nums of R is, so the rightmost is smaller than or equal to nums of R, or middle, less than equal to nums of target. Okay, does that even make sense? It doesn't make any sense. Hold on. So we're saying the nums of target, so target is 3, So yes, you're smaller, but the nums of r is bigger. So that literally makes zeros. Oh no, that's not true. So we're saying nums of r. Okay, wait. I got all of this wrong. Let me do this again. So if the nums of L, so if the nums of left, okay, if the left is smaller than the, yeah, so like for example, like let's say we're here, right? Like 0, 1, 2, right? Like that scenario. So if we're less than or equal to, or less than nums of target and less than or equal to target, I guess we could say equal to as well, right? I don't like the idea of equal to, but it's fine. So we do here. So like if it's ascending, then we need to push oh, what target? What am I saying? It doesn't make any sense here. Nums of target. So if nums of target is less than or equal to, like if it's ascending like this, 0, 1, 2, then and target is bigger than not target, what am I saying? This is middle, right? Which is nums of mid, right? So if that's the case, so the middle is it doesn't make any fucking sense at all. Wait, actually, so target is 0, right? I would have returned true early. Let's say here is this now, so it actually would go to the right side, but this is the case where it's like ascending. So like the left, middle, right. Oh, left. So the leftmost and the target is there and the nums of is bigger. Okay, now that means it's way too big, so we need to do r minus. Otherwise, that means we're on the right track, so we'll just increment. Because if the middle is bigger than the target, we need to move towards the bigger side. If the nums of middle, right, is less than target and less than equal to nums of right, so that is the case like this one. So like nums of middle is less than the target and less than r, or r, right? That is like this scenario right now. Then that is, so 0 is less than 3 and r is not. That actually would be the opposite case of the else case, right? So if that's the case, then we need to move I'm not sure, actually, hold on, where do we move here? If we move perfectly ascending, if you ascend perfectly here, then it's going to be like this is a case where it's 0, 2, so it's 0, 3, 2, so that is a violation, or yeah, 0, 2, 3. So that is, if the basically if the rightmost value is not even that big, we need to move towards the bigger side, which is this side, right? Else we just do mid plus 1, yeah. Oh, maybe, hold on, I don't do this. Okay, hold on, what am I missing here? I feel like I'm supposed to skip duplicates. Let me see this. Let me get all rid of these. Yeah. No. Okay, I'm not. So like, what about snares like this? I think these are fine. We can say equal to. We can say equal to. But I don't want to say oh, no, 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 no. I never want it to be equal to the middle. Yeah, I didn't like that. What? Okay, hold on. I'm not understanding something. Okay, can the numbers be equal to? Wait, okay, does this even make sense here? Equal to here, less than target. That's fine. I think that's fine. Wait, I think I got this flipped. We're saying if the nums of m is less than or equal to target, right? So that's a scenario where the middle, and the rightmost value are all this way. So we want to move to the left here. Yeah, we want to move towards the thing. Otherwise, for example, like this case, we want to move towards the right. So that's that side, yeah. Really? TLE? I thought this was binary search. What? Oh, wrong answer. Whoops. Okay. What am I missing here? No. Oh my goodness. Okay. The middle shouldn't equal the target. It should always... The target could be the right side, actually. Actually, yes. If the target is the rightmost, that's fine, too. That means we should move towards that direction, yeah. Like, we should definitely... Like, if this is the rightmost and it's actually the target, we should want to move towards it. Okay, no. And then the middle... No, that doesn't make sense. If we're the leftmost is the target, like, for example, like, if it's 2 here, right? If it's 2 here, like, let's say the target is supposed to be 2, we want to go towards that. So, yeah. So, we bring down the R. So, yeah, that makes sense. Really? TLE, bro. What? I thought this was binary search. That doesn't make sense. Bro, what? I think there's an infinite while loop. That's... Oh, wait. So the target could be equal to the ends. The target, yep, that's fine. Return. Oh my god, wait, hold on. This is the fucking wrong signs. It's supposed to be plus and minus. Bro, fucking finally, bro. Jeez. Alright, see you guys tomorrow.